Hello and welcome to the Wednesday night modeling stream. Oh, hope I didn't crack your speakers there. I'm your streamer Bryan Bentley for CG Spectrum. For all your 3D modeling needs, go to go to spectrum.com/3D-modeling. I'm Bryan Bentley once again, department head of modeling here at CG Spectrum, and this is my stream. This is, like I've said it time and time again, it's my favorite part of the week because I get to sit down and just work on stuff. And I don't get to do that as much as I would like. So what have I been working on? I've been working on this. So we've been building this procedural feather system. This is going to be attached to a character that I started a long time ago. I want to take this character to completion, a lot like I did with the Cortex robot. This is much more organic. So it's going to take a little bit more work. It's probably going to take a little bit more time. Probably going to be working on this for, a month, maybe 2 months, because I don't really do much work in between these streams. I did do a little bit because I kind of got struck by lightning, and I thought I figured out a better way to do the fanning of the feathers, and I think I have. It works a lot better, so I'll explain that. But other than that, this is pretty much where we left off with last time. Just give me a second. Let me close my office door. There we go. So this is where we left off. I have my reference in here. I'll reference brought into Houdini. If I do ghost other objects, I can see. So there's my reference. So hopefully today, we'll see how far we get. But what I want to do is I want to address some of this, what I call Z-depth fighting, this stuff here. Very clearly laying on top of each other, and they are not laying on top of each other in this scenario. Now, I do have that little Z push that will, that kind of takes the feather and kind of pushes it this way so that the feathers kind of go like this along the line, but I kind of don't like that. What I would rather do is I think, once again, I'm just testing this. I've never done this before. I think I would rather just rotate about this axis. So instead of like this, it's rotated like that. So they're all rotated like this. So that they're kind of like blinds, like Venetian blinds. How Venetian blinds kind of like sit like this. They're not directly flat. They kind of like rotated and they kind of sit on top of each other. That's kind of what I want to go for. So yeah. So we'll see if we can get to that. And I'll explain the difference in what I did to the previous stream. Cool. Awesome. All right, let's get into it. So, like I said, I haven't really done much. The things that I did do is I changed the shape of these nodes. So I've changed the shape to be circular if it's kind of like an important node that I'm going to have to change a lot of stuff on. And actually, I forgot those. Those should be circular as well. Let's see. 0 to 1. 0 to 1. I really don't need these anymore. Let's get rid of those. And then this is my normal tangent. Cool. All right. So, let's see. Okay. So, we started with, just to recap, we started with our wing geometry. We made an edge group. And we pulled that edge group out. We then carved this, and then we resampled it. So let me turn on my. All right. So that resample is picking up those normals from the object, but I was trying to mess with these guys last time, and I think last time what I did is I actually duplicated this and moved it out with an edit node. Now that worked, but it wasn't very procedural. Like I couldn't really go in and just move a slider and get a different look. And that's what I really want to go for. I usually want to just have a slider moved off to the side. I can just go and I can change the whole thing instead of having to go in and say move this point, move that point, then move that point. Okay, so this is a transform here, just to move it into place. This one's not doing anything. This one over here is doing a little bit to move those second ones into space. And so this is where I go and I change my normals. So what I'm doing here is, and I'll show you how this works in a minute, but I'll show you the idea behind it. So originally what I'm doing is in here, I'm taking and I'm setting all my normals. Let's just get a better angle on this. I'm setting all my normals to just point straight down. Like this. Like that. And then what I'm doing is I'm going to construct a quaternion that goes out this way, and I built this at the origin, so this is just Z, right? And then I can then rotate this vector around that normal, right? And I can also modulate that with a curve U. So remember, I have a curve U that goes from 0 to 1. So I can take that 0 to 1 and say, okay, remap U to some degree A, and remap U to some degree B, and then slide in between them. So let's say this one gets rotated 0, and then this one on the end would get rotated, let's say like 90 degrees. So that would then point out that way, and then you get this fanning effect. Okay, so that's what's going on inside of here. So I'll show you the actual network. Okay, it's not really that big. What am I doing? I'm taking my curve U, and I'm plugging that into a ramp, right? So that's how I map that curve U. So it's the same operation that's going on in the remap value node. Exact same math. Okay, so I can remap this 0 to 1 to anything. So I can say, instead of going a straight line, I can put a curve in there or whatever. So that's 0 to 1. So then I'm taking this now fit, and I'm saying fit that 0 to 1 to a new destination minimum and destination maximum. Now this new minimum is my start rotation, which I call this, and my maximum is my end rotation. So start rotation is going to be here, end rotation is going to be here. Okay, so those are degrees, because we tend to think as artists and people, we tend to think in degrees. In math land, we have to do everything in radians. So I take my degrees and I turn them into radians, and I put that into that fit there. Okay, so then I can take and I can construct that quaternion. So this quaternion is a angle and an axis. Okay, so the angle is Z. So the angle, like I drew before, is this, or sorry, the axis is like this, and the angle is whatever that user controlled rotation is along the axis there, like that. Bang. Okay, so then I just use this really handy Q rotate. Okay, so I take this Q rotate, and then I'm Y. So this is 0, -1, 0. So that's straight down, and I'm rotating this vector by this quaternion, and then I'm spitting that out to in. So I know I went through that really fast, but it's the same stuff over and over and over again. That's why we record it, so you can go and look at it again. If you're really confused, we want to learn more about this, you can go to cgspectrum.com/3D modeling, or the other great resource for this type of thing is a website called CG Wiki. He's got like a whole section on what's called the joy of Vex and SOPs. He's got DOPs. It's basically, it still is my Houdini Bible. Anytime I get lost in the woods, I usually go back and I'm like, okay, there's got to be something in here that I can use, or something a way to go. So what I've done now here is now I have, so my start rotation is 5 and my end rotation is 90. So now I can control my start and end rotation. So if I want this to be 90 or 180, right? So I can control this now. And if I want my start rotation to go back the other way, I can do that as well. So I can pull this back in this direction. Right? So that is a much easier way to control these vectors than that extra stuff. Hey, Phoenix Studios. So our VFX course, actually, you know what? Our VFX course is great. It's ran by a guy named Daniel. He does some amazing. He's doing like on his stream. He's doing like this great like ship coming out of the water type stuff. I do more modeling. Like, this is the modeling stream, so I do more modeling, and I use everything. Like, I've been using Houdini a lot, but I'll probably jump back into, you know, Substance Painter and Maya and ZBrush here pretty soon. But for stuff like this, you can't beat the level of control that you get with Houdini, with this procedural stuff, especially with things that you need to be very, very, you know, you can iterate on very quickly. Like, with Houdini, like, I could have gone in and placed each one of these feathers individually, but once again, I'm always trying to think in an art directable manner. I'm always trying to think, okay, well, what if I show this to my art director, I show this to somebody, and they're like, oh, those are too many feathers, or those aren't enough feathers. Like, I don't want to have to go in and delete feathers and, like, basically redo everything. With this system, they can say, oh, we want twice as many feathers, and I can say, okay, if my feathers are 0.0, 0.1 apart, I can do 0.05, and then I automatically get twice as many feathers, and everything still works. So that's the idea. Okay, so this is just a null to denote, you know, a curve going in. I might not need that now because this all kind of works as one big unit. So yeah, so I can now resample this guy to my heart's content. So I have these two resamples in here. So I think I'm going to leave this first resample alone. Yeah, so I left that last one, that first one alone. So this is the actual controller. It's 28. So I think I had 18 in there. Doesn't really matter. So these are now my new normals, right? So I'm now going to build my P scale and scale off of here. So you can't really see that, but if I click here, and let's turn off points. So I have my P scale here that goes from 1 to... Oh yeah, my P scale is 1, and my scale is what's driving this, because I want to scale this non-uniformly. So I have this guy and this guy. So I set this one up. And then lastly, we have this this build my constraint here. So if I view my Orient, so there's that. So you can see my Y directions line up perfectly with those normals now. Okay. And then I have this Z push. So this Z push, if I go to my top view, so it allows me to push this one direction or the other. So if I pull it, if I start to push this out, actually I need to do that. So it's pushing one way or the other. So that's how I can get them to not overlap. But I think I'm going to add my Orient so that I can rotate each feather individually. So we're going to do that. And so I kind of rewrote this, but the old one will work just fine. So I'm going to get rid of these actually. Okay. So now if I come to my feathers and I look at my feathers, so there are my overall feathers. So I want to work on these first ones, these main ones. I think I went too far with my Z push. 1, 2, 7. I think I had it as, yeah, there we go. So I'm going to work on these ones, and then I'll basically copy this over to this other Z push. So I'm just going to look at these guys here. Don't need that merge. Look at this color. Okay. So so in this build Orient here, right? Remember, I have that Orient. So what I can do is if you have a quaternion, right? And this is my Y direction overall. What I can do, it doesn't look like a Y, it looks like an X. So that's a Y. So what I can do is I can make another quaternion that's just Y, like this, right? And if I multiply these together, basically I will turn this one by this one. And this is how matrices work. This is how rotations work, right? If I take one matrix and I multiply it by another matrix, I'm adding instructions together. Now, there's really no operation mathematically to add a matrix. Like, you can't add matrices and subtract matrices from one another. You have to multiply them, but it's like a set of instructions. So, like, if I were like, it's like a pirate map, right? If I said, you know, walk 30 paces that way, then 20 paces that way, then 20 paces that way, that's like a matrix. It's an instruction. Now, if I have another set of instructions and I multiply those together, it'd be like, okay, walk this way, then that way, then that way, then walk that way, then that way, then that way, right? Multiply together. Same thing with quaternions. So let's see if this works. Hopefully my math isn't super rusty. All right, so I'm going to pop in this build Orient. So I have this, matrix to quaternion, and then this is going out to my Orient. So what I need to do is I'm going to multiply this quaternion by another rotation quaternion. So I'm going to say, make me a new quaternion. And it takes an axis and an angle. So my axis is just going to be y. All right, so I'm going to make a constant. That is a vector. And it's going to be 0, 1, 0. And that's going to go into axis. And I want to be able to control the rotation of these, so I'm going to make a parameter. And this is going to be feather rotation. Okay, so I want to, this is going to be an artist tool, or this is going to be an artist parameter. So we're going to say this is going to be in degrees. So I'm going to say degrees to rot. Degrees to radians. And that is going to go into my angle. Okay, so this is my extra rotation along y. Now I just need to multiply these together. So I think it's quaternion multiply. There we go. So A multiplied by B. Now, unlike regular multiplication, I believe that the order of this matters. So let's see what this does. So right now, this parameter is at 0. So let's just start to rotate this and see what we get. Actually, yeah. Yeah, so there we go. They're kind of rotating. Now 30 degrees is probably way too much. It is getting like this really cool rotation. So let's do maybe 5. Yeah, that's actually feeling pretty good. Maybe that's even too much. Maybe 2. And let's take our Z push and set that to 0. Yeah, that's working really, really well. Yeah, cool. And already that's starting to look a little bit more organic and not so flat. Just to make sure, I'm going to actually flip these, Shift R, and see what that does. I think that actually might be more what I want. Let's see. Yeah, actually that's more what I want, right? So now they're rotating along that y-axis. Cool. So that's what I want. So I'm going to do maybe 3, 4. Yeah, 4 degrees. It doesn't really take much. Doesn't really take much. So now this is nice. This is very, very nice. If we look right at the top of this, right, they're ever so slightly angled that way. So we can see this if I start to, yeah, very ever so slightly angled along there. So let's do 3. 2.5 maybe. So that's actually very, very nice. Very, very much. So much more control than I had before. Okay, so I'm just going to take and duplicate this, and I'm going to replace this guy here. And we'll take and we'll plug this in. Yeah, so for these, I'm using the Z push to kind of move them around. But that that rotation is working way, way better. Yeah, cool, awesome. So that works really well. So let's get rid of that. And I'm going to save this. Yes, 3. Just gonna clean this up real quick. Shift L. Okay, so I got these 2 streams, and these are almost like so much identical. I could probably almost turn these into a DSA or a digital HDA, not DSA, HDA. So that I don't have to keep on maintaining parity between the two. But that might be, I might do that later. Right now I'm just trying to get the whole system up and running. Okay, so next part. All right, this is going to be the challenging bit. Where I did direction to them, like they're kind of like this, and there's a lot of them. And they're scattered kind of over a surface here, whereas these are just kind of like flat and like coming out. These are kind of scattered over a surface. So I want to try to get those working, or start to build those out. Okay, so to do that, I'm going to come way back up to this guy. So when you're working with the fur tools, you need a what's called a skin VDB, or a skin VDB. And so what that allows you to do is it allows the skin VDB it's a surface, or it's a volume that knows where its surface is. So anything inside of here is going to be, I think it's 1, and everything on the outside is -1, and everything right on the surface is 0. So internally, what Houdini knows is like, if it says, all right, if there's a point here, it says, oh man, I'm inside this guy, so I need to be outside that guy. Or if I want to go the opposite, if I'm out here, I can say, oh, I'm out here, I need to suck down to the surface here. So that's what volumes and VDBs do. With surface data, like geometry, like NURBS and polygons, the only bit of data is right here. You don't know, like if there's a point here, you don't know if you're inside this object or outside that object. So that's where volumes come in. Okay, so I need to make a closed surface to make that volume, and then I need to kind of resample this a little bit, because right now it's like really what's the word I'm looking for? It's very low poly. So I need a little bit higher poly to work on. I need more points to like start to paint stuff on and do all that stuff too. So let's do that. So let's see, how do I want to do this? I want to put a cap on this first of all. So I'm going to do a poly cap. Actually, what I'm going to do first is I'll subdivide this first, just to get some more data. So maybe we'll do 2. And then I'll do a polycap. Okay, so there's that. Let's do triangles. Yeah, that works. Cool. Yeah. Do I want 3? No, because I'm gonna resample this anyway. Okay, so I have this guy. So now what I'm gonna do is I'm going to remesh this, because I want even more polygons. Now I'm probably not gonna use this mesh. This is just so can you actually extrude or create thickness in certain parts? Yeah, technically. I don't really. Can you restate the question? I don't really understand what are you talking about the feathers, or are you talking about the actual kind of like chicken wing that I'm working on? Okay, so I want to remesh this. So I'm going to do a remesh. And by default, this is going to be way too small. So I need to take my target size and I just have to bring that down. And what I like to do is I like to template this so I can see when I start to get close to the original. Yeah, so let's do 0.01. Okay. Okay, so now I have plenty of stuff to start to paint on and to start to build from. So the other thing I want is I only want to grow hair on these top parts. I don't want to grow hair like in here or around like there. Like I basically want my hair to go like that. So I'm gonna use my geometry. Like I said, I want to keep as because I could just go in and like paint this in and do it by hand, but then like it would be hard to edit. Like I try to keep as much proceduralism as I can overall. Just turn down some of that smoothing. So what I'm going to do, so I know that there's a line that goes around the outside of this, so I can use that. So over here, let's see. Let's take one of these edge to curves. So I'm going to take this guy. Okay. So I actually want to close that out because I don't want stuff growing here either because that's going to slot into the back of the character. So I'm going to take and I'm going to do an ends. And I'm going to close this. So I'm going to say close you, and I'm going to say close straight. Bang. Okay. So what I can do after this is I can do a carve. It should open that up again. Yeah. But now I have, let's see. Might have to do another ends. Oh, I think I need to do another ends to open this up. Ends. And open with new points. And then I'm going to carve here. There we go. Yeah. So now I can carve this out however I want. And I can use both of these. So if I want to get just the bottom, so I can take this guy like that, and I can take that guy like that, and that's my one mask. So this could be my bottom mask or top mask. So I don't want to kind of cross contaminate this too much. So instead of doing that carve there, I'm just going to put a null, so I can call this thing whenever I want. So I'll make this thing like a bright red. So I know this is gonna, so I'm gonna call this out wing curve. Okay, so now what I can do here is I can bring in that wing curve and I can start to make masks based on that wing curve. So the first one I want is the one that kind of goes down and around to here because I want to mask off where I want this stuff to grow. So here, what I'll do is I'll do a object merge. And here's a cool thing you can do. I can just drag this thing directly into that object. So if I view that, I get that. Okay, so now I can take that object merge. I'm going to color that red as well, just so I know that these two guys are connected. So you color code everything, try to stay organized. And now I'm going to carve this. Okay, so I want to say keep outside and don't want any fur growing there and want any fur growing here. So this is my bottom mask. So there's a bunch of different ways to use this as a mask. One of the newer and super fun ways is called mask. Let's see, mask. Mask. Along geometry, mask from geometry. Exactly what I was looking for. Okay, so what I can do is I can here, and I'll plug this guy in here. And so I can visualize this mask now. Bang. So let's start to pull our radius down, and you can see I'm starting to mask off where I want that to be. And I can change its sharpness as well. So if I want this to be really sharp, I'll bring these guys together like that. So you get a lot of control out of this. A lot of control out of this. Now the thing is this is all 0. This is all 0, and this is all 1. Now I want that inverted, so I can invert that. All these red bits are where my feathers are going to go. I don't know why I'm getting that one little bit. That's strange. It's distance, parameter. Distance to surface. Okay, there we go. Distance to surface. That seemed to have fixed it. So yeah, so I can control that mask procedurally. Super dope. Okay. So this is, I'm going to put a no, I don't need to do that. I don't need to do that. Okay. So now I want to grow hairs, furs. Oh, actually, before I do that, I want to go ahead and make that VDB for my skin. So I'm going to come here and I'm going to say tab VDB from polygons. So this is super, super coarse, so I need to bring my voxel size down. Okay, so that's feeling pretty good. Like, this is a really, really dense, what's the word I'm looking for? VDB, but I'm not deforming this. I'm not moving it. I'm only using it for collision, so you can get a little bit more heavy when you get with that. So this is my skin VDB here, and I think I'll do the same thing. I'm gonna put a null here. Just want to try to keep this as organized as possible. So, null. There we go. Out. Skin. VD. Okay, so back to here now. So now I want to grow my hairs. So I'm gonna hair. And so the hair generate, it takes a rest skin, guides, and animated skin. So I don't have guides or an animated skin, so I'm just going to do rest skin. So there, now I'm getting my hair growing off this. So now it's growing along the normals, but I have my hair. So now it's kind of growing from everywhere. So what I want to do is I'm actually going to do Control and Alt and click this guy. So I can see I'm working on this one, but it's actually rendering that one. So I can see now that like all this is still growing on those parts where I didn't want it to grow. Down here, there is a spot for direction. Where is it? Ah, density, here we go. So I can add more bits of fur if I want this to be really, really fuzzy. Okay. I want to work with speed, so I'm going to keep this pretty low for now. And so way over here, this little nondescript guy says no override. So I'm going to say skin attribute. Okay? And that skin attribute should be density, right? But right now, if I look at this guy is masked. There's two ways I can do this. I can rename this attribute to density, or I can just put density in here. So what I think I'm going to do, yeah, let's do attribute rename. Attribute rename. So that's going to be a point attribute. I'm going to rename mask to density. I think I copied that. No, I did not. And boom, just like that, shaved all that stuff away. And so now I'm gonna make this a little controller shape, because that's a pretty big deal. Okay. Because with this guy, now I can control exactly where I want that to grow. Pretty snazzy. Okay, so now I can say, all right, let's see how many of these. Okay, so these are way too dense, way too dense. Like I really only need for this, I really only need 2 points. So down here as well, I'm gonna say, let's see, where is it? Segments. I'm gonna take this down to 2. So now I only have 2. Oh no, I just need 1 segment. So I have 1 here and 1 here. The reason I'm going to do this is because, once again, it's all about that rotation vector, right? It's all about that rotation vector. So now I have something that goes like this, right? And I can control that. I can control where that goes. So if I have a second vector, I can build a third vector. And then I can build my feather can be built however I like. So my feather, let's get a different color. My feather can be built like this. Right? And so on and so forth. Okay, so we got where we want them to grow. Now we figure out how we want them to grow. So there's a couple different ways I could do this. I could brush this down. Like once again, I could use a guide groom and brush this down. Use a screen brush. I could show you that. So let's see. That's hair curves, and that is skin. Okay. So I could use a guide groom. And for regular hair, I would definitely use this. So this is, let's see, it's guides, it's hair curves, and this is skin. Skin goes in here. Okay. So with this, I can use what's called a screen brush, and I can just brush this down like that. Okay, but now I want some of these to go down, so I want it to go like that, and I want some of those to go like it's just. I mean, it's art directable. It's nice, but then like some of these are now going into the skin and things like that. So I think this last one is so that's the skin VDB. So that's what the skin VDB is for. So let me go back if I want to use. So I'm gonna say reset all strokes, or it's actually reset strokes, and I'm gonna go grab that skin VDB. So I'm gonna do an object merge, just like I did with. I'm going to take this guy, grab that skin VDB, throw that in there, and we'll make these both the same color. We'll make them, let's say, this there, skin color. So what this allows me to do is now, if I run that screen brush again, when I comb this down, you can see that these guys are trying to stay outside of that shape. Now, sometimes they can't because it's so low. Sometimes they can't, and you get like weird directions and stuff like that. And sometimes you can get like these bald spots and stuff. But, I mean, this is the way to do it. I prefer to work more procedurally than this, but it's a way to do it. Like, if you want to just get in here and, just like straight up just comb stuff in, that's one way to do it. So that's one way. I prefer to be a little bit more procedural about it. So one thing that we can do is inside of Houdini, what we can do is we can generate velocity. We can generate what I call static velocity. It's just velocity information. It's like as if you took a snapshot of wind. If you've ever seen those like kinetic sculptures that are like, they're like little panels that flip their direction based on wind. It's like that. Like if you took a snapshot of any one of those things, you can usually see like these flows and eddies. And they're really cool. You can do kind of like the same thing in Houdini. So what I can do is I can make a curve that flows like this, and then I can make other curves that flow like that, and then those will push around these hairs dynamically. And if we look, right, this looks a lot like our wing. So I could probably use the same idea. I can probably just go steal those normal vectors and build that way. And I think that's what I am going to do. I can also scale these based on I can scale and rotate them based on the normal. So those tools that I spent so long. Hey Sarah, Pixie. Hey Brian, recently graduated the bachelor's degree through Call Arts. Nice to meet you. Animation being my elective. Houdini broke my brain. This is so cool watching other people do this kind of stuff. Yeah, Houdini is kind of katana. All right. It's one of those things. It's like a lot of pain up front, and then once you kind of get over that hump, that horrible learning curve, everything makes sense. Well, not everything. Most things make sense. That's one of the things I really enjoy about working in Houdini, is that like it has this overarching philosophy that doesn't really get broken in many spots. There are some parts where it deviates a little bit, but in general, like it's geometry, primitives, and attributes. And if you can master those three things, and you know what like the attributes are doing, that's really all the nodes are doing. They're just modifying attributes. Like they're modifying positions an attribute, velocity is an attribute, p-scale is an attribute, scale is an attribute, color is an attribute, right? So that's what all these nodes are actually doing. They're just modifying these attributes. So along those lines, what I'm going to do is I'm going to copy this. I'm going to use this as a velocity curve. So I don't need, so we'll take that. I'll probably use it again in a minute. So I'm going to make a velocity curve out of this guy. I'm actually just going to regular template this. So I want this velocity curve to go along the top and not the bottom. So I'm going to say keep inside. So that should give me just the top. And I'm going to do much the same thing as I did way over here. So let's geometry, point size, let's bring that up. Okay, so here are my points. And I think this is enough, right? I have 12 points. I think that's enough. I don't need this. I don't need this to be. Yeah, it takes a while. Like I've been, I haven't been working in Houdini as long as other people. So I've probably been working in Houdini about seriously. Like I dabbled in it for like a couple years, and I've probably been seriously really trying to get into it for about probably 2 years now. Like this last year, I really dove in. And really kind of got my teeth into it and really kind of tried to learn how to do it. So yeah, so there's that on top. So the other thing I want to do is I want to generate those normals like I did before, I believe. So I want to generate normals. So let's see. I'm gonna just grab this. I'm gonna copy it. I'm gonna bring it over here. Normal rotation. Let's view those normals. Yeah, so that still works, right? And this is the great thing about modular design is, let's see, let's make sure those still works. Yeah. Oh, for this to work, I need a resample node. So I need that curve U. And we'll go ahead and resample this to something sane. So yeah, so there's my there's going to be my flow vectors. Now I do kind of want them to go off to the left and off to the right. So that would be, so that's going to be my can this be exported to Unreal? I would assume it would be. Now this setup in particular, I mean, you could export this setup to Unreal. You would have to use, to get all this functionality and stuff, you would have to use Houdini engine. But what we're going to end up doing is this is all just going to become just polygon geometry at the end of the day. It'll be like feather cards with a feather texture on them that has an opacity texture on it, and that will get, you know, exported to Maya or Unreal or Unity or Godot, whatever game engine you want. Or you could even just like render this inside of Mantra. My background is from visual effects and feature animation, so I wouldn't go to a game engine. I would stay in Houdini, or I would stay in Maya with Arnold or RenderMan, or, you know, something like that. Or I would export you would export geometry caches like ABC files, and you would chuck those into Katana, and then you would render them that way. But it doesn't really matter, because at the end of the day, it's all points, lines, faces, and normals and texture data. So however you get there, it doesn't really matter. Yeah, cool. All right, so next thing, I'm going to go and grab my build Orient. So I'm going to copy that and put it over here. I think I need as well, I need tangent U. Yeah, so I needed that tangent U and curve U, and then that builds my normal, and then that goes into that. Okay, so the other thing is, so right now, so this guy, this is now rotating, yeah, this is rotating along that Y, right? So what I want to do is on this guy, let's do 0. I want to rotate not along my Y now, but I want to rotate along my X, because I want to rotate this outwards like that. So I'm going to just pop in here, and instead of Y, I'm going to do X. So now if I rotate, should get, yeah, so that kind of pops out to the side like so. Okay. And I'm hoping this will work. I haven't, like I said, I haven't done this before. Okay, so those are going to be, let's turn off this. So these are actually going to be my flow curves. So I'm going to have one flow curve that goes this way. Actually, let me make sure that's going in the right direction. Now this curve is going actually in the wrong direction. Like I want it to go this way. So right now it's flowing, 0 is here and 1 is here. So it's going that way. I want it to go this way. So I should probably reverse this curve. I'm glad I checked that, because that would have made a very strange looking feather setup. Okay, so my curve here, let's do a sort. And in my point sort, I'm going to do a reverse. So now my 0 is here and my end is here. We resample that. Maybe that has to go after the resample. Yeah, and then now I'm going to have to change these guys. Oh, no, I don't have to do that. And then these guys, cool. All right, so now this is going this way, and this is feathered out a little bit like that, right? So this is all to build a velocity system. All right, so I have my, so this is my main curve. And then this is going to be my side velocities. So I'm going to take and I'm going to copy. I'm going to make a line, and I'm going to copy the points. That line. Yeah, there we go. Okay, so I can mirror this now. And I want to mirror in the negative z direction. Kind of looks like a boat at this point, but and then I'm going to merge that back with my original. So let's turn off all this data. You can see what we get. Okay, so we have this this spline that's moving down like this, and then we have these very controllable lines that are going like that. So I'm going to have a velocity that goes this way, and then I'll have velocities that flow downwards. Like that. Okay, so how do we use this now? There's a really neat node that just basically takes curves and turns them into velocity. So I'm gonna say velocity. What is it called? Velocity field from curve. Velocity. Where is it? Volume rasterized curve. Ah, here we go. Volume velocity from curves. Bang. Okay, so it wants a curves. So they're my curves. It wants a surface to flow along. So that's going to be my skin. So let's go ahead here and make another null. Call this out skin. Duplicate this, drop that in there, make sure that's both of these are one color. Okay, so that's my skin there. So once those two things, and it makes a really weird looking floppy curve, right? So if I look at this, right, I have this one, and I have a volume called velocity. Right, so this is kind of hard to see and visualize, but let's bring this down. So this kind of weird smoky stuff around the edges here, that's actually my velocity. Now it's visualizing it as a fog, but trust me, it's there. Ooh, maybe that's a little bit too much. Okay. Let's see if I can do a visualize. Volume visualization, maybe. So anybody that's watched this stream knows I'm not the best with volumes. Let's do high field. But that's why we're here, right? You're always here to learn as much as you can. So this is my operator tree. I want my tool palette. There we go. Let's do volume. Let's see. There should be a visualize volume, visualize velocity, volume trail, volume VOP. Volume analysis, volume blur, volume bound, break. Volume slice, I think. Yeah, there we go. Okay. So we have this volume slice, and method is volume. No. Mesh. Plane is the XY plane. I want to view Vel. And yeah, so there's my velocity. So my velocity is encoded in curves. Like that. So also kind of hard to see, but you get the idea. Density. Vel. Yeah, Vel. Should be Vel. So if I look at this here, I should get Vel. And yeah, so I have data in Vel. So that's a little confusing. Maybe I'll try to figure out a better way to visualize that. But in this case, it's fine the way it is. Okay, so now I have my curves here. And so what I can do is I can take and I can say, hey, Houdini, push these curves around based on this velocity. So hopefully I've done this correctly. Volume, velocity for curves, volumes, blah, blah, blah. Okay. All right. So let's take and do let's go to hair over here. And it should be called Advect Guides. Guide Advect. So Advect is a fancy way to say push something around with velocity. So let's see. So my guides, hair curves. Second one is skin. So there's my skin. Third one is skin VDB, skin VDB. And fourth one is my velocity and collision. So let's do it here. Ooh, not bad. Pretty close. Kind of close to what I want. Let's turn off this guy. Not bad, looking pretty good, looking pretty good. So I think I might be getting a little bit too specific on this. Because some of these are getting, let's just try this. Like I said, haven't done this before. Let's look at this guy. Start to rotate this out more. Is that going to help or hurt? Let's see which way these guys are facing. It's kind of hard to tell which way they're facing. Let's see, that's 97, 96, 96, 97. So let's try and let's turn off that sort. Doesn't seem to be doing much. let's make sure my line here is going in the right direction. So 0 to 1. 0 to 1. Maybe. Carve. That helped a little bit. And maybe I can bring my line length down. It's not too bad. Looks like it's grabbing these ones from looks like it's grabbing these ones from the side here. It's like these are going here. So let's try this. If this is a little bit too specific, let's take out this mirror. And let's go 0. And let's remove this mirror. Oh, that's much better. That's much, much better. Yeah, so I think I was just getting a little bit too specific with my velocities. So really, I could just have the 1. And so now, I should be able to, normal rotation, I can take and I can push this around a little bit more. Yeah, that's actually not too bad. Okay, cool. So here are my kind of velocity advected guides. The other thing I could do is I could just draw these on if I wanted to. I still feel like this guy is going the wrong direction. Yeah. I think that might also be it. Like this one, now so we can see that this is all flowing this way, right? I want it to flow that way. So let's try to diagnose that. So this sort doesn't seem to be doing much of anything. Okay, so how would I reverse and mirror a curve? So that sort really isn't doing much. So I think the main thing is I need to get this curve here flowing this way. And it doesn't seem to care about point order. So maybe a reverse. Yeah, that's definitely doing something. It's hard to tell. So whenever I'm in a situation like this, what I'll do is I like to use color to my advantage. So for this, I'm going to do a resample. And I don't want to actually resample. I just want that curve hue attribute. And I'm going to put a color. And I'm going to color by RAM from attribute. Attribute is going to be curve hue. And I usually make these really, really grossly garish colors. So red and green. So I can see exactly where everything is going. Okay, so that's good. That's what I want. So my red is my tip, and my green is... so if I turn this off, so my red's here, my green's here. I want stuff flowing the other way. So that goes there. So not a sort, but a reverse is what I wanted. Here, and here. So get rid of that. I basically want to reverse the direction of that. Okay, so now here I have that, and let's plug that back in and see what we get. I probably should have done that color trick earlier. There we go. There we go. That's much nicer. That's much, much nicer. So I think what was happening is this was trying to force these feathers that way, and then this was trying to force it that way. So I was getting like kind of like this shearing effect that was kind of strange. So let's go and let's bring back that mirror. So let's go back and we can take and let's go and rotate these back out. Like so. And then we'll mirror this as well. Once again, this might be too specific, but we'll see. So I want to mirror in negative Z. Merge those two together. That should give me my velocity field. And let's see. Oh yeah, I think that's better. So I might also have to actually reverse this side. So let's try that. So let's do this. And so this is the problem solving process. A lot of times, and I say this, I'll probably say this at least once a stream or once every other stream, is when it's easy to kind of get this kind of false sense of like, oh, everything just works and everyone knows how to do everything and everybody is so much smarter than you than I am or anybody else. When you're watching YouTube stuff, especially like paid stuff, like stuff from Gumroad or Flip Normals, stuff like that, those are very curated. Those people went through and figured out how to do all this stuff and did all this problem solving beforehand. So they basically did all this for you so you don't have to do it. Now, I do this in the stream because I want you to see it's iterative, right? You have to like go down a certain path and be like, oh, that's not working, and then try to figure it out, and you stay here for a little bit and you're like, okay, that's working now, I try to put this back in. And that's what I really like about node-based stuff, is that you can like chop pieces off and like replace pieces very quickly. And yeah, so it's quite nice. So let's see if let's just take just this and plug it in. Let's see what that does. No, that's actually okay. That's going the right direction. Oh wait, maybe it's not. Hang on. I remember. Yeah, this is going the wrong direction. So this is where that color really, really comes in handy. My green is going up this way, and my red is down here, right? So I need to, nice, Esteban. That's what I like to hear. People are like, right, my red is here, my green should be down here. If I take, before this, yeah, my red should, so basically my reverse, this mirror needs to be reversed. So, not too hard to do. I'm going to take what I learned up here. I'm going to reverse just this side, because I turned off keep original. So now I'll just merge these three parts back together. So I'll merge my center line, my left, and then my right. So yeah. So here. This is going to go into here. So that's one side. This is going to be the other side. Let's clean this up so that my wire's in the right spot. Let's just do Shift R. There we go. So 1, 2, 3, 1, 2, 3, and then we'll plug this guy in here, and fingers crossed. Boom! Yes, there we go. There we go. I like that. I like that. So let's see if I can flare these out a little bit more. I might not need this carve either. Yeah, don't need that carve anymore. I wonder. Yeah, cool. And then the other thing is, let's see. I think this third one might be a collision volume. Perhaps. Let's see. Let's just test. Let's see. Reference volume, activate voxels, voxel size, interior, flow surface. So it's flowing along the surface, which is kind of nice. Fill interior. Oh, there's a little lift on here if I can do. Ooh, there we go. That's what I like. That's what I like to see. Nice little lift built in. Look at that. All right, I like that. I like that. That's really nice. So super controllable now. Super duper controllable. So this is a little tangled. So let's clean this up a bit. So actually, I generally don't like spider webs like this. So what I'm actually going to do is I'm going to do 2 merges. So I'm going to do 1 merge for these guys. So those guys will get merged together, and then slice those off, and then that will get merged into here with the main line, just to keep it nice and tidy. And then this doesn't seem to be doing anything. If I disconnect that, yeah, that's not giving me anything. I'm not really sure what this third input is for. I'll have to look that up. But in any case, so this is all our velocity volume to push stuff around in space. And the cool thing is it's once again, like the way I did this, it's all procedural. So I can come way back up here. So I'm going to template this guy and come way up here and view this guy. So now I can take, and if I don't want those curves that far down, I can take my radius, start to bring that radius up, and it's just going to knock out those curves. And I can come even further up, or actually I can come down here, and I can bring my density up or down to add more or less feathers as I see fit. It's very art directable. Extremely art directable. Okay, the next thing I want to do is, let's see, I want to make sure that, do I have normals? Yeah, I have normals on here. Nice. Okay, cool. So I have my normals, and in my hair gen, I want to transfer those normals over to my curve primitives. So my kind of like my feather primitives. So point attributes, I want to transfer in. Okay. So if I come way down here, way back down here to my guided vex, so I view this, I should have an in value on my primitive. So I have skin prim here, prim UV. So that's getting picked up from the skin data, and then I have this in, which is going to work really well. Hopefully, it'll work well. So I have a few of these feathers. So I'm going to go back to my my reference here. So I feel like these end way earlier, right? So I think I want that mass to kind of be down here as well. So actually, you know what? No, I think that's all right. I think that's all right. I'll get the whole thing working, and then I'll visualize that. So, and I think these ones here need to point down a little bit more, I think. So start rotation 90. Let's do 0. Yeah, there we go. So we get a little bit of more of, and this is what's great about this, right? You have like this really finite control over exactly where stuff is going to go. I might need to pull up that density a little bit. So let's do that. It's always good to see this stuff in context. So let's go to my other feathers. So I might need to lift these a little bit more because I need them to cover these guys. Always good to see stuff in context. So Vex. Surface lift. So I like this. So I like this lift here. Like this is nice. But I feel like these up top are getting a little bit too spiky. So I think what I'll do is I'm not going to do the lift here. Like I know I can lift it up and I can get something like this, but kind of want. Let's do flow surface. I do like that flow surface. It's not really giving me much. Smooth velocities. Ooh, I do want to smooth out those velocities a little bit because my data is a little sparse. So for this, actually no. I think I liked what I had before. So I'm going to turn off this follow surface for now. I can always come back to it. And I think what I'm going to do is I'm going to use a guide groom on this. So this is like my visualization, my direction visualization that I was using. So the first thing now is I'm going to collide. I'm going to say collide with VDB. So we have our guides go here. This is skin VDB, and then this last one is additional VDB, so let's say skin VDB. It's not really giving me much either. That is my skin VDB. So it's not really giving me much. I was pushing it out a little bit, but not too much. Getting the surface offset. So that's just pushing them outwards. So these are just like, so once again, these are just very much singular. Actually, that's actually working pretty well. So these are just singular sticks, right? So there's going to be no bend in them. So I think that might be what I'm reacting to. But it's always good to Be wary of these things. Actually, that is actually not too bad. Let's see. Let's turn on flow, follow skin again. Actually, yeah, I like that. So follow skin on my guide advect, and then a little bit of surface lift to collide with the skin underneath. I think I like this. I like where this is going. Yeah, I like this. Cool. My feathers here are a little bit too far, but I can deal with that later. That's like kind of like the beauty of, once again, the beauty of the proceduralism. I can just make everything work, and then I can massage everything. I can do stuff in passes. Okay, so let's do this. Let's take all of this guy, and we'll color that, say blue. Actually, all this is blue because this is all just blue. And we'll put a net box around this as well. Just so I know exactly what I was doing over here, because this is kind of weird. It's a little esoteric. It's not 100%, visible what I'm doing. So we'll say bell curves. And then this is like going to be my hair generation here. Okay, so let's work on, now we have, like I said, we have that in, and it's on a primitive. So if I were to draw this out, so let's say we have like these 3 hair curves. Okay, they each have a point on either end. So here, here. We're also getting a normal value from the skin. So let's say this guy's normal goes like that, that guy's normal goes like that, that guy's normal goes like that. Right. So what I can do is I can generate another vector that's just this guy, this point, minus this point. So if I take 2 points in space and I subtract them from each other, I get this. Right? So now we have 2 vectors, just like we've been doing over and over and over again. I can take the cross product of this guy and that guy, and that will give me a vector that goes here, goes here, and goes here. And then I can take the cross product of this guy, and that'll give me a vector that goes there, goes there, and goes there. So then I have my orthogonal frame, and I can stick my feathers onto those as I see fit. So that is really cool. Okay, so I'm going to do that with an actual point wrangle. Or do I want to do it with an attribute valve? It'd be easier in a point wrangle. Prim points in an attribute valve. No, I'm going to do it in a point wrangle. So this point wrangle is going to be, it's going to run over my guides. And this is the thing I love about Houdini, is that, well, of the many things I love about Houdini, is that the hair curves, they're just curves. They're not any special type of data or a special type of object. So if you're using like XGen, which is great for hair generation, XGen or Yeti or way back in the day, shaving a haircut, stuff like that. They're those hair strands, like kind of like these special objects, right? They're curves way down underneath, but they have all this extra stuff on them that makes the system recognize them as hair curves. The only thing that Houdini cares about is these attributes that you stamp on it. It's like, okay, this is a piece of geometry. I've stamped this attribute on it. and so now I recognize you as a curve, but because or as a piece of hair, but because it's just a curve, I can do whatever, you know, operations that I could do on regular geometry on this data. So it's really powerful modeling tool, not just for this type of stuff, but for anything where you have to make a bunch of stuff. So, yeah. So, what I want to do is I want to get the first and last point. So that's going to be called. So I'm going to say, oh man, I got to remember how to do this. Int. Let's do is prim points. So I'm going to look up the usage of this. So So I know this, I'm pretty sure this spits out it spits out an int array. So prim points, geometry, and prim num. So I need to put this in a variable. So that's int, I believe this is the syntax, int points equals prim points. The geometry is going to be the first context, and the prim num is going to be at prim num. See if I've done this correctly. No, int, maybe my brackets need to be here. I always forget where they need to go. There we go. Yeah. So this says that this is now an array. So it's going to be an array of 2 because I know that I only have 2 points. So so this let's see, returns a list of points on a primitive. So let's say I have a line here, and this is kind of hard to wrap your brain around. Let's say this is point 10 and this is point 11, right? This is this function is going to return a list of 10 and 11. Now I can get to that by saying this is my 0 element and that's my 1 element. Okay, so let's do this. Say int start point equals points sub-0, not the Mortal Kombat character, and int endpoint equals points 1. Cool. So I have my start point, I have my end point. Now I can say vector tangent equals endpoint minus start point. Sweet. So now I can just write this to an attribute. So v at tangent u equals tangent. So if I've done this correctly, I should now have a tangent u attribute. Hopefully. Let's see, where is it? Should be primitives. Skin prim, skin query. Oh, I am running over points. I need to run over primitives. So just give me 1, 1, and 1. Let's see. Num. So let's go ahead and just write out I at start equals start point and I at end equals end point. I just want to see what these are. Make sure that they're actually, I'm actually getting data. Okay, so start 0, 2, 4, 6, 8. That's right, because I have 2. And then my ends should be 1, 3, 5, 7. Yeah, that's right. Oh, that's what I need to do. Duh. I can't just grab. So these are just integers, right? So I need the position of these, not their point number. Right. Point. Point. O-I-N-T. Can't type. Point. Point attribute from a value from geometry. So I need to get the geometry, the attribute name, and then the point number. So the geometry is 0. The attribute name is, I want its position in space. And then and then the point number. So once again, point. So I always have a lot of students ask me, I was like, oh, should I learn programming? Should I learn programming? And my answer is always yes. It's always yes. Because without a little, like, I don't really know that much programming. Like, I know enough to be dangerous. All right, let's see if that works. There we go. Now we're getting some meaningful numbers. So I don't need these guys anymore. Okay. Always good to debug. Okay. So now I have this tangent u that is that's, you know, stuck on there. My primitives. So I need to push that tangent u from my primitives to my point data. So I'm going to do an attribute promote. So I want to promote from primitive to point that I want to be tangent u. And maybe last match. I don't think this should matter because it's across everything. So I should see down here in my points, I should now see a tangent u. And so let's view this. Fingers crossed, it looks correct. Marker vector. There we go. And there's my tangent u. Bang! Ha ha ha! Sweet! And then now I have my tangent u and I have my normal. So I also need to promote. So let's promote that as well. So I'm gonna say this to this. So I'm gonna say give me. So there's my normal information. So now I have the two pieces to make that rotation matrix. This is fantastic, super great, super cool, or at least I think it is. Okay, so now I can just do that double cross product yet again. So this guy is, say, let me save this before I break something. Build tangent. Promotes tangent u, promotes in. So now I can start to build that rotation matrix. So I'm going to do that with an attribute vol. Build Orient. so I have my in there. I need to bring in that tangent U. Tab, bind, tangent U. It's a vector. And I spelled it wrong. Haha. Let's say tangent gent U. Cool. And so I want to make that matrix, that vector to matrix. So vector to matrix. Okay, so I know I want my tangent U to be my Y, right? Because remember, I'm building my feathers so that they sit on the ground here and face straight up in the air. So that tangent U is going to be my Y. So tangent U is going to be my Y, straight off the bat. Okay. So I want to take the cross product of, and actually, you know what? This is so big and bulky. I'm just going to do this. So I have my tangent U and my in. So my in, like, this is going to be throwaway. So let's see. Okay, so yellow. This is tangent U, and this is going to be in. So the cross product of these two is going to be X. Okay. So we'll call this Y. This will be X. So in tangent U, that's going to be X, and then the cross of this and this will be Z. So I'm just going to grab this, pull it out. This is going to be Z. So the cross product of Y and X should give me Z. Plug in there. People call this a double cross product method because you have two cross products. Okay. And then, so we take this matrix and we turn that into a quaternion. Matrix to quaternion. Matrix 3 to quaternion. And then out here, I do a bind export. You guessed it, Orient. So now I have an Orient. I should be able to now see my Orient is afloat right now. Override with input. There you go. There they are. Haha. Nice. So I can see most of my Y's are pointing out this way, most of my Z's are pointing out that way, and most of my X's are pointing out that way. So, bam. Nice. Love it. Super cool. Okay, so I think I can test this. If I just put a sweep on this, I should just drag some geometry onto here. So this is just temporary to see if this is working. So I'm going to do ribbon. Yeah, not bad. Let's make their width. Bring that down. So it looks like the sweep. Doing what I want it to do. Yeah, it is. It is. It's doing what I want it to do. Oh, that's what it is. Okay, the columns are long ways. The the rows are determined by what's the word I'm looking for? By the points along the curve. So that's not too bad. I'm getting that kind of like fanned effect, right? So I think looking at this now, my density is way too high. It's way too high. So we'll go back up to here and we'll bring the density down. Yeah, so this is always going to be a difficult piece here. Like, how do you deal with this? But like, I'm going to be looking at this, and let me turn. Let's do this. Let's do where is back faces? There's a way to turn off that darkening of the back face. I can't remember where it is. Detail, quality, subdivision, wireframe, impacts, point instancing, spiral. There is a way to turn off the darkening in the back faces, and I can't find it. Textures, multi-texturing. Oh, where is it? Node guides, node handles, display nodes, current geometry, template geometry, selectable geometry. Oh, where? Ugh. Alright, I've spent enough time looking at this. Doesn't really matter. But what I wanted to get was something. So actually, what I'll do, just to kind of unify this whole thing, I'll do the same thing over here. Yeah, that's not bad. So I think I was like, oh, I don't really like those back faces. I'm getting a little bit of bald spot right here, but I am gonna probably texture the underside, like that under with something as well. And there's nothing to, you know, take this layered approach. So basically, I've been completely procedural up until this point. Now, at the very last point, now I can come in with a guide groom and start to comb some of this up and down. So let's do that. So let's do guide groom. So same thing with the guide groom. So this is all guide stuffs. So these are my guides. Nope, nope. It's my guides. Let's go for skin. So it's my skin. And this is looking for the VDB. So this guy is flowing down through here. So this is my skin VDB, and skin VDB. So what I can do now is I can start to do some hand cranking. Now, this kind of maybe goes against what I was saying before, but I have to do much less of this in the, like, I'm just icing everything out, right? I'm finessing. So I'm not doing much. So if I do had to go back and change something, like my entire setup is not this kind of this hand motion stuff. So I can just kind of lift this stuff up just a little bit, just so it fills in. Not too much. Like that. Yeah, so that feels a little bit better in there. And I can still work on this while I'm viewing the other stuff. Kind of want these to flare up a little bit at the end, and maybe these up by the shoulder will flare up a little bit as well. And the nice thing is, so it's caching all these strokes. So this is one of the things that, and I usually color these type of things bright red, because if I come back up here, and I change my density now, if I go to change my density, notice nothing is moving. So if I go up and I have more density now, so let's do 11,000. Nothing's moving. I have to come all the way back down here, and I have to remember to press recache strokes. And so it'll take those strokes and it'll reproject them onto the work that I had done before. So that's a little dangerous sometimes. I'm just trying to fill in these holes a little bit. And once again, that might be too dense, but I'm getting like this beautiful, beautiful complexity, but it's like very, very controlled. And this is still all proxy geometry. Like I'm not even like gotten to the point where I'm actually putting feathers on this. So yeah, so I can do a guide groom. I can also do a guide process after this if I wanted to lift this a little bit more. So let's do a guide process. And I probably should do the guide process before I do the guide groom. Guide groom should be last. So I'm going to do a lift. 1, 2, 3. Those go into there. And this goes in here. So if I turn this off, I'm just getting a little bit of lift over everything. Maybe I don't need that much. You can also do randomized lift to kind of give it a little bit of more furry look, if that's what you're going for. I actually kind of like that, but I'm going to bring these closer together, so there's not so much variation. Yeah, so let's view both of these together. I'm pretty happy with that. That's fantastic, if I do say so myself. Yeah, so that's the top feathers. So I think I'm gonna call this good. I might do some finessing around you know, between the streams, but I like where this is at because I'm going to see this about here. Like, it's going to be on a character's back, so I don't think I plan on getting super close up. But yeah, I want to put a wing geometry. And actually, you know what? Let's just go ahead and do this. Let's just go ahead and go the whole way. So I have this feather here, right? So I'm going to copy all that. And instead of that sweep, I'm going to do a copy to points. So what I want to do, I don't want to copy this to all the points because I have points at the start and the end. I just want to copy to the root. So I can do a group expression. Okay, and I think there's a preset in here for either start of curve or end of curve. Doesn't really matter. First point of primitive. Perfect. That's exactly what I want. And I want this to be points. So now it's just going to give me that first point of primitive. I'm going to call this roots. And I'm going to say, I won't need the sweep anymore. I'm going to take this guy. I'm going to say copy to points. So that's my template. So these things are gigantic right now, so I'm going to take this whole thing and I'm just going to scale it down. And I only want to copy to roots. Let's see what's going on here. Looks like some crazies going on. Let's look here. So I need to check and see. I'm just going to do a blast. Do blast 0 and delete non-selected. Okay, so there's my 0th feather. And actually I'm going to do this before I go to my group so I can work on just one. Let's see what my feather's doing compared to my line. Oh, how'd you get way over there? Haha. All right, so that should be 0. You rotated it all? No? 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 So let's look at my my Orient is off. Okay, so my Orient's off. So let's look at let's go back and let's see if that tangent U is still there. View my tangent U. Ah, there we go. So my tangent U is off. Okay, so that's probably in my attribute promote somewhere. So I'm actually going to view this guy. So that my tangent U is off. So I want my tangent U to be going straight down this line here. So it's a tough one. Let's do maximum maybe. Nope. Average. Minimum. Last match. So this is where the problem solving comes in. So I'm gonna disconnect this guy, and let's do here. Build tangent U. Okay, so that works. That works. Oh, let's bypass this guide groom for now. Guide process. Ah, that's what it is. Okay. My guide process is moving my but it's not pulling around the attributes with it. Okay, that's fine. So that's how I've diagnosed the problem. So this is what we'll do. I'm gonna take away that guide groom because I can do that by hand later. So I'm gonna take and guide process first. So actually, what I'll do is I'll take this. I'm gonna duplicate it, and we're almost out of time here. Guide process. This is gonna go up here. This is gonna go down here. I'm just gonna do some little. Delete that. This guy, my guide process comes first. Now, what comes out of my guide process, so if I turn this on and off, that's changing my lift. So that's my lift. So now this is going to go here. This guide process is now not needed. So this is going to go into here, and that should go into there. And let's do that blast again. And 0. And this should take us just out of time. Delete not selected. There we go. Yeah, so that's lined up now, and fantastic. Okay, that's lined up now. Cool, 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 cool. Nice. So let's put that away. There we go. Very, very nice. Okay. So a little bit of digital sleuthing, so we can get rid of these two guys, and this goes away. This goes to here. So I get my colorful. Do this. I want these to be kind of wide, but then I want them to be pretty short. So T Y. These are like those short, fat feathers. Oh my word, that looks awesome. Oh man, that was worth it. That was so worth it. So much worth it. So that gives it just like a little bit more character. All right, that is it for the stream. Woo! Got in right under the wire. Let's look at this whole beast together. Poochow! Look at that. That is absolutely wonderful. So I can lift these out. I can comb these out if I need to. I can make them longer. I can make them shorter. Let's come in here and just make this a little bit longer, just a little bit. Yeah, there we go. I can even control the width or the length of this based on whatever I want. I can comb this stuff down. Like, this is great. This is wonderful. So this is looking really, really good. I like this a lot. I like where this is going. I can control the density of this. I can control the density of this. I can control all that stuff. So modeling with data. Everything is data. This looks really, really good. I cannot wait to get the actual feathers onto here and get this thing start to get this thing textured up and start to look real good. So I'm gonna have to do some finessing to kind of merge this stuff in and kind of pull this stuff down, but that's all doable. Okay, great. That is the stream. A little bit over time today, but I had a really good time. This was super fun for me. I hope you got something out of it too. Remember, you know, if you're not uncomfortable, you're not doing it right. Like you have to stay uncomfortable, right? Like you need that. As humans, we need to step out of our comfort zone. You want to get stronger, you have to lift more than you were lifting before. You want to get faster, you have to run harder than you've ever run before, right? So you have to push your limits physically and mentally at all times. Don't get comfortable. Do not get complacent. All right, I will see you guys next week for all your modeling needs. Once again, go to cgspectrum.com/3D-modeling. I'm Bryan Bentley. You guys are awesome. See you next week. Peace. Wash your hands. Drink water.